First talk after lunch. Please take it away.
Hello everyone. You probably read the title. An angel, Python, root and config walked into a bar. My name's Hjort, and you guys are probably wondering, why did they do that? And who let this guy up here? Like, that's probably not a good idea. So, welcome to my talk. So, my name's Hjort, as I mentioned. I work with vulnerability research at Outpost24, a Swedish cybersecurity company. My work is primarily focused around automating vulnerability detection for already known vulnerabilities. I have a Master of Science in Engineering and Computer Security, missing one physics course, but almost. I think hardware is cool. That's how I got started into this field. I like software architecture, especially the consequences around them, like what happens if you have a poor design in your software architecture. And I love cheap hardware. So, our focus is going to be the consequences of subpar patching and poor software design, as you might have surmised from my previous sentences. We're going to be looking at a device from a company called Zixel. It's a NAS 326. Or we could also just be honest and say that I'm going to be standing here and brag. So, we will be talking a little bit about how the design of this thing caused quite a few issues, right? So, earlier this year, I released a blog with the help of my company about 5 different 0 days on that device. And it's contained, for example, an unauthenticated Python code injection, a remote code execution and a config upload, and a sudo-like privilege escalation, and some other information. And most importantly, a backdoor called the NSA Rescue Angel, the angel part of our joke. So, we'll begin by how this process actually started, because it might be a bit interesting. So, at some point in time, I was tasked with finding an already known vulnerability that IBM had found, called ZVE 2023-27992. It's a Python code injection. And I worked on it before they published their awesome blog that's describing how they did it. So, I worked on it, and my work involved unpacking firmware, decompiling binaries in Python bytecode, and digging through it. And at some point, we did also purchase the device that was involved here, so we could start testing on it. And back then, I didn't really find any interesting. It wasn't... I found the thing I was looking for, but nothing else. But we had a student evening at some point, where students from a local school or university, whatever it's called in English, they were coming to our company, and they were going to get to see what are we doing. And I was tasked with representing my department and show them a typical case of what we do. And I thought that this IBM thing was very typical, because it involved a lot of research, decompiling, and magic. It made me look cool-ish. So I got back to it and revisited my work to prepare the presentation slides. And when I was doing that, I was being a little bit slacking on the job and started digging around into some unrelated files on it. And I stumbled upon an interesting binary with the SUID bit set. Now this is local on my machine, but on the actual device, it's owned by root. So I looked at this interesting name, Remote Help CGI, that's cool. And I looked inside it. Specifically, I unpacked all the strings I could find in it, and I found some funny strings. So open backdoor.sh and NSA Rescue Angel. And my thought here, preparing this student presentation thing, was, well, that's suspicious. So we did a presentation, yada yada, things was successful, and I asked my boss, hey, can I continue poking into this device, because, well, it was end of life at the point, but I still wanted to dig into it because this looked very interesting. And I happened to know that Zixel had a couple of similar vulnerabilities with remote code execution that did get a lot of media coverage. So, yeah, I got permission, and that's why I'm here. So you can probably guess that. So we will talk a bit about how this thing works. Specifically, we'll focus, first of all, how does this NAS, like a web server specifically, how does it handle our requests? Because this is, well, it's the software design, right? It's the cause of our issues. So I made a pretty image with a terrible color scheme, I'm sorry. So we got a client, they speak to an Apache server, and all of the requests will be going through an authentication module, and after that they will be passed on to a handler, which is either a Python server or some CGI binaries. We will dig into them a little bit later on. So we know this file, the remote help CGI, it's got some funny content, right? It's got these funny strings. So let's focus on it first because it sounds delicious. So what does it do? I'm trying to avoid boring you guys with code, so I will more explain about how it works instead of showing you code and letting you read it, because this is a presentation, so It takes strings that are the names for a list of callbacks, and if the string happens to match something in that list, it will take the callback and execute it. And it's got two interesting callbacks related to those strings that we saw, right? It's got the backdoor callback, and we can maybe guess what that thing's doing. But sadly, it's calling a SH file to do its task, and that one did not exist in the latest version at the time. So I ignored it. This was a previous vulnerability patched in 2020. We will discuss it a little bit later. But it did have one called SSHD TDC, which was new. And it was doing basically the same thing as the old SH script, where it starts the SSH server, if it's not enabled already. It's going to map port 22 to the internet using UPnP. That's where you disable UPnP on your home router. And it's also going to generate a password for that account, because we cannot give it the password ourselves. And it's going to do this based on the Ethernet 0 MAC address. And it will append TDP to that output it's calculated, and then it enables the user, which, by the way, has root privileges, so it's pretty bad stuff. Awesome, it's my thought. This looks super cool. But it's authenticated, so that's kind of suck. Because on this device, well, if you already have an account, you basically already compromised it anyways. So, nah. But this device is kind of cheap, in my opinion. It's not a Cisco super expensive thing, so I know that developers tend to like being wet. Write everything twice, and so I thought that, hey, let's look into historical vulnerabilities. They might be relevant into what I should start focusing on. And yeah, I looked at the change logs, and I'm so happy that this looks sort of readable. There's a lot of mentions about authentication bypasses, pre-authentication command injections, and other command injections. The list is long. I couldn't fit all of them into this presentation slide, so whatever. We can probably find one more, was my thought at this point. So let's look at the authentication mechanism. IBM will also describes this on that blog that they had. I do recommend reading it. I do also recommend reading my blog, obviously. It's better, but I'm biased. So the authentication mechanism has one task, right? It's going to take a request and it's going to categorize it into two groups. Either a request is authenticated or it's not. It's kind of simple. The thing is doing then, right? If it's of a authenticated request and you have a cookie, we're happy. And if it's authenticated and you don't have a cookie, you're denied, and it's going to blast your request to hell and send you back to the login screen. The quirk here is in how this thing is checking the whitelist. And this is related to why they keep having these stupid authentication bypasses. It's looking for substrings. So it's assuming everything is authenticated by default and then it has a whitelist. And that's good practice, right? But for example, we happen to have this icon in our web browser that's giving this, like, you know, when you get into the website and it's going to show this icon for the website up in the corner, the favicon.ico file. That's one of the stuff you don't want authentication for, and so it's in the whitelist. And so what's going to happen now, right, is if this favicon ICO file is unauthenticated, i.e. the request is valid without a cookie, we're happy. If foo/bar is authenticated, it's going to be invalid alone. But if we happen to add favicon.ico in the end, or in the middle, or in the beginning, it's going to be unauthenticated. Hooray, great software design. So, and here's an interesting part, right? It's an Apache web server, and it has a lot of request handlers like scripts and CGI binaries and whatever. And it's the server and also then the authentication module is not aware about what paths is actually valid the moment it gets handed off to a handler. So what it means is if you have a path to a handler and appends something to the end, the authentication module doesn't know what's going on. So this means that all of the handlers, like all of the endpoint that's in a handler, it's got to then know its own path, right? Because someone's requesting it. And it means then that it's got to be able to make sure that nobody is appending favicon.ico at the end. And it's also got to know then, does it require authentication? And if it does require authentication, it's got to remember, how do I validate this cookie? And it's also got to remember to validate the cookie. I think we're starting to see why there's a lot of authentication bypasses here. So, in my opinion, the authentication module is useless. Like, it doesn't really do anything. We can't trust it. We get a request that's been through it, it's authenticated, but we can still not trust it, so it's not good. Hello? There we go. Real quick, this is how the request for the backdoor exploit looks like. I won't be deep diving into how all of these pieces, where they come from, and whatever, read the blog. It's good, but still, I'm biased. There is an issue, as I mentioned, with the backdoor exploit, right? We need a password. We can't give it the password, and we do not receive it in response. So, how do we get it? I mentioned, right, it's calculated based on the Ethernet 0 MAC address and appending TDT on it. So, we as an attacker need to either know the MAC address of this thing, or we need to have access to a shell. So, I targeted a command injection, since I thought it was cooler, and also I happened to stumble upon it. And the Python code injection, right, the part in SherryPy server, it's Python 2.7, so version ancient. And looking at the control flow of how it's doing things, it's great design. The endpoints is determined, like what we're calling, by calling eval on the user input. So this is a great design for us. So if we request something like foo baz, specifically what it's going to do is it's going to take the two first parts, shove it into an eval import controllers.foo, and call eval controller.foo.bar, and then pass it some arguments. This is the main control flow for all of our requests. It's all of our Python requests that are going to go through. So, and this is important here, that baz is not getting included into the execution. So what IBM did back in their blog was that they appended this favicon.ico thing at the end of the path because they targeted these endpoints, right? They didn't manage to abuse the eval, but they did find one of the controllers that called system, and they inserted backticks because they forgot to filter the user input, and it exploded. So they patched this by restricting the request path to only contain like the each section in the request path. So it can only contain A to Z and underscores. So dots are no longer allowed, so favicon.ico doesn't work anymore. And they also restricted the path on these endpoints to a maximum of 2 directories. So if we append like something at the end, well, it's not going to be valid anymore. So the problem is to begin with this whitelist thing, right? If we don't have anything valid in the whitelist, we're still not going to be happy. So lucky me that they had something in the whitelist that did not contain the banned characters. But we could still not append it to the endpoint on this path because, as mentioned, they restricted it, the number of paths in it, or directories. So how do we find an authentication bypass to this Python thing now, right? There is a limit to the length. I present to you a new endpoint that they added in a patch. And this endpoint, we won't be reading the code, so don't look at it too much, it's ugly. It's doing this right. They didn't learn. They forgot to restrict the number of directories permitted in the path. In fact, it's not even looking at the path except for it's banning it's not allowed to ban characters, but as long as there's no banned characters in the path, we're happy. It's running eval again. And the interesting part now is that the request body is what's getting called in the eval, and the request body does not have the limitations of A to Z and underscores. We can put magic characters in it, with some limitations. We're not allowed to use $signs and backticks and whatever, because they patched IBM stuff. But the interesting part about here, right, you guys can't really, you can see my mouse, perfect. The args argument here is the body that I'm sending them, and it's a string at this point. They are passing it in by value to this percentage %s in the arguments part here. And that means it's not going to say args, it's going to be the content of args. And that's good fun. This is important, right? Because if we say A equals a string 2 plus 2, eval print A is going to print 2 plus 2 because it's a string, right? but if we do the content, it's going to be 4. And that's what we're abusing. So we exploited it, and essentially we built a big-ass request. Once again, read the blog for the super details on how this thing works, but essentially, I tracked down an endpoint or a controller that does not validate the cookie, because as I mentioned, all endpoints need to validate the cookie themselves, and they happen to forget it here. So I escaped the function call, and I added my own stuff to it. And I called a utility, executed a utility called makeKey, which is what they use in the backdoor to calculate that password that they're appending. So, and this code injection happened to be reflected, so I get the output back to me as long as the handler doesn't crash. Yeah. And a funny thing about it then is that they did not ban things like double ticks and parentheses and underscores and I don't remember all of them, like commas, I think. So we can base64 a payload and set an eval around it and set the eval inside the eval, so we can eval our eval and get request back. Joe Dog. But sadly, and this is why I'm still targeting this despite it being a backdoor, right? Because this is nobody. So we don't really have any privileges as this user, but we're allowed to execute the makeKey utility. So it's a little bit sad. But at this point, right, we have everything we needed for the backdoor, so I was happy here. But then I also happened to stumble upon a couple of bonus things here, like a local privilege escalation that I mentioned. I was thinking like, oh, if only we had something like sudo, but without password. Well, lucky me, they happen to have that because this web server needs to do some admin stuff. And obviously we had sudo without passwords. But it needs an absolute path to whatever it's executing. So /bin sh, and now we have a sudo shell. Whoops. So how do we get here, right? It's a quick recap in case people aren't following exactly. They have a broken authentication module looking for substrings. That means we cannot trust it anymore, so all of the endpoints after it has to do the validation themselves. Everyone has to remember to do this. They fixed the off-bypass that IBM found in the CherryPy server by limiting the path and by banning certain characters. And the next time that they added an endpoint, they re-implemented it, forgot to limit the path restrictions, and they forgot to put the double quotes around the args variable, so suddenly they did not reference it by name, and it's by value instead. And now, oops, we have another vulnerability. So it's very easy for them to re-implement the vulnerability in this device. And if you're reading through the changelogs, this is very, very noticeable. Like they keep patching the same thing all over again. So, looking at the stuff of interest that we've discussed here, like they patched a backdoor back in 2020. That's the open backdoor.sh file we talked about. Then they patched IBM's command injection in 2023, and sometime in between they re-implemented the backdoor and added a new command injection. And like doing this cheap, I call it cheap code. Like it's not really well thought out. It's probably maybe the argument is it's a lack of skill, or maybe it's to save money and time because they don't want to waste time on this stupid device, right? But in the end, having to keep patching the same thing all over again, like that's cost a lot of money and a lot of time and a lot of effort, and it's super annoying. The patching of the stuff I found was that they killed that new endpoint entirely. Not sure why. And the backdoor function is still present on this device. But they're making it exit early, so it's present-ish. I decompiled it and dug through it. I think what they're doing is they're calling exit 0 at the beginning of the function. So that's good fun. So yeah, some key takeaways from this presentation, if I wasn't clear enough about this, is that my thought and what I wanted to talk about and bring up to attention here in this presentation is that quick patches is not exactly a good way to do things, right? Because it's going to waste more time in the end, having to redo it all over again. Because I've been bashing Zixel all over, like every time in this presentation now, they were really good to work with. Like I contacted them, told them everything, and they were like, "Oh shit, fixed it," even though the device has been end of life for like half a year. So they did good. So that's good, and that's much better compared to some other vendors I'm dealing with right now. So yeah, an angel, Python root and config walked into a bar. If you want any easy CVs, revisit them. Their patches is probably a good joke. That's it.
Well, thank you very much for your talk. Are there any questions in the audience?
Hi, thank you for the talk. I was wondering, I have two small questions. One,
Okay, just hold the mic closer to mouth.
the code for the servers, I'm guessing they were open source, right? And the patches for them.
You mean the server that you're using?
I mean, yeah, because I saw you showed some code of the servers, and like for example, the way you saw the new endpoints. Are these your own code or you found?
No, they are delivering Python bytecode, so it's not really text, but Python is really nice that you can just reverse the bytecode back. You even get the comments back. So.
Oh, I see. And another small question. I was wondering, the name you found, the NSA Rescue Angel. Do you actually think they belong to NSA? Because
nah.
Because I wouldn't think they would put the same name in the like.
Yeah.
They wouldn't self-snitch on them.
So NSA Rescue Angel would be too obvious, and I don't expect NSA to maybe be that obvious to begin with. But what I think is that I think this is like a support account. It's for when Granny has some internet problems and they need to fix it. I think that's the reason why they have this.
I see. Thank you very much.
Yeah. There was a guy behind him that had a question as well.
Thank you for the talk. You mentioned that this device was end of life, but is it possible that this applies to currently shipping devices as well? Did you look into that?
It's been on my to-do list. So this does affect at least one more device that they themselves have confirmed. I don't remember the exact model name, NAS356 or whatever. But I would expect them to be reusing this code a little bit everywhere. Because last time something big like this happened, it did affect a lot of devices. So I'm personally planning on expanding my network stack by buying a Zixel switch and maybe accidentally killing it. So it's on my back burner to do.
Any other questions? Yes.
Hi, thanks. So you stated that the password for the National Support Agency account, you can compute it based on the MAC address. Have you investigated the entropy of MAC addresses in these things? Because maybe there's only like 100,000.
Yeah, I looked into the MAC address. They are assigning them themselves. So, and I looked into what ranges of MAC address they have, and I don't remember the number off the top of my head, but yeah, it's brute forceable. So that's why I mentioned it was two ways of doing calculate or find it out.
Sure. Thanks.
Any other questions? Yes.
Thanks for the talk. Is the authentication module wrote by themselves or the open source or the open source solution?
The authentication module, they coded it themselves, I think, because the more exact name would be like zymodoff. So I'm assuming it's Zixel.
So they wrote everything by themselves.
Yeah.
Cool. Thank you.
Any other questions? No? Okay. Well, then I'd like to thank you very much for your talk.
Yeah. Thank you for listening.
Thank you for challenge.